Okay, we are on page 12 in our packet. We're going to go through some practice problems over the stuff you guys saw in your last 2 notes videos. So this lesson, it wasn't a lot of content, but it was kind of spread out over a lot of real estate in your packet, if that makes sense. So your notes were over 2 days. So you covered a little bit of this each day. I give you 2 pages each day for your notes. So now we're going to take a look at this kind of all in conjunction with our practice problems. So we're starting again on page 12. And what we're looking at is solving polynomial equations using graphs or tables, okay? For the examples that we're looking at today, our graphs are provided to us, but you did also look at some examples specifically with your Delta Math yesterday, where you had to graph functions on your calculator or on Desmos. So for today, the difference is that our graphs are given to us. So if we take a look at number 1, it says, what are the solutions to x squared plus 4x equals 0? So I've got the graph here of x squared plus 4x. And then if I want it to equal 0, that means I'm looking for x-intercepts. The 2 big options that we had when we were solving using graphs was, does this function equal 0 or does it equal another thing? Okay, if it equals 0, we're looking for x-intercepts. If it equals another function, then we're looking for those points of intersection. Here, since we equal 0, we're looking for x-intercepts. Okay, so I'm looking for where this function hits the x-axis. So that would be right here and right here. So -4 and 0 would be our real solutions because those are x-intercepts on the graph. Right, we can see those solutions as x-intercepts on the graph. Now, based on the degree of our function, how many solutions do we expect? 2, right? Back to our fundamental theorem of algebra, we expect 2 solutions. I have 2 real solutions. So how many imaginary solutions would I expect from this graph? 0. Now let's look at our function equal to -3. So -3 is down here. Since I'm equal to something besides 0, I'm looking for intersection points. So I'm looking for where do these 2 graphs intersect? That would be right here and right here. Remember, we're only giving those x values. Okay, my solutions are x values here. So my x values would be -3 and -1. Those are the x values for my intersection points. Now, based on my function, right, same thing on the left, but now equals -3. Based on my function, what's the degree? Still 2, right? I didn't add any more x squared or x cubed or anything else crazy. I didn't multiply by anything with an x. Our degree here is still 2, so I still expect 2 total solutions. We have 2 real solutions, so how many imaginary solutions do I expect? 0. There shouldn't be any. I expect 2 total solutions. I have 2 real ones. That'd be 0 imaginary solutions. Anytime that you do have imaginary solutions, remember it's always going to be an even number. So it'll be 0 or 2 or 4 or 6 or 18. Anytime I'm filling in how many imaginary solutions do I have, if you're ever writing an odd number, something's wrong. Okay, go back and double check. You should never be telling me an odd number of imaginary solutions. Now let's take a look at our table. For our next couple problems, we're going to use this table here. We've got x values, and then I've got f of x, y values. So these are the y values for f of x. And then these are the y values for g of x. And it tells me what f of x is equal to and what g of x is equal to. Okay, so here's our x values. And then if I'm looking at f of x, these are the y's. If I'm looking at g of x, these are the y's. My first question using this table is, what are the solutions to x minus 1 equals 0? Okay, so that's an x-intercept, right? That's when y is 0. Because y equals 0 at x-intercepts. So I'm going to look at, this is x minus 1, that's f of x. I'm going to look at when does f of x equal 0. So my f of x line, we're 0 right here. That's our only place where we're 0. So I have an x-intercept when x is 1. So my real solution there is 1. Based on the degree here, how many solutions do I expect? Just 1, right? I have 1 real solution. How many imaginary solutions should I have? 0. Now, what are the solutions to x squared equals 0? So that's g of x. And again, when I'm looking at when it equals 0, I'm looking for x-intercepts. In a table, that means I'm looking for when is y equal to 0, right? Just like above, we said y equals 0 at the x-intercepts. So I'm going to look for when y is 0 in my table for g of x now. So here's a y value of 0. That's the only place. And it happens when my x value is 0. How many total solutions do I expect out of this function? 2. I've listed 1 real solution. So what do you kind of want to tell me for number of imaginary solutions? You kind of want to tell me 1, right? But what did I say just a minute ago? I have to have an even number of imaginary solutions. Like, it's not 1. So let's think about this graph a little bit more. This is the graph of x squared, right? Our parent graph. And we've said here we have an x-intercept at 0, 0. If I look at the other points here, I've got -1, 1, and 1, 1. So this is my graph here. I have an x-intercept at 0. What's the behavior there? It's quadratic behavior, right? So this is going to count as 2 because this is quadratic behavior. So that's the only time when these get a little bit tricky is if I have quadratic or cubic behavior at that x-intercept. I have to pay close attention to how many that counts for, the multiplicity. So since I've got quadratic behavior there, this x-intercept actually counts for 2 solutions, which means I've got both of them here, and we have 0 imaginary solutions. Okay, and then finally, what are the solutions to x minus 1 equals x squared? So here I'm going to look at where g of x, oops, this is f of x, where f of x is equal to g of x. When are their y values equal? So I'm going to go to my table and look at where the y values are equal. I want the y values to be the same. I'm ignoring the x's for right now. I just want the y values to be the same. Nope, 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 nope. I didn't get any places where the y values were the same. What does that mean? What was that? There's none, right? They're the real solutions? None. Looks like these things don't intersect. If I thought about the graph of this, and you could graph these each in your calculator, but if I just look at my sketch here, we know that this would be our x squared graph. And then x minus 1 means, bless you, we have a y-intercept at, boy, this is hard to see, -1, and a slope of 1. So we're gonna, right, they're gonna just miss each other. They're not gonna intersect. My parabola's gonna keep going up. My line's gonna have this constant slope this way. Those graphs aren't gonna intersect, which means we would have no real solutions. How many solutions would I expect from this function? 2, right? Degree of 2. Okay. So how many imaginary solutions should I have? 2. Yeah. If I have no real solutions, that means they both have to be imaginary. Questions forming so far? Okay, turn the page. I think we have 2 more problems on the next page that are the same stuff. So at the top of page 13, We are using our graph here. I've got f of x, and then g of x is this line here. F of x looks like maybe a cube function. Okay. 6 says write an equation to represent that the solutions are x-intercepts of f of x. So I'm focusing on f of x first, and I want the solution to be the x-intercepts. If I want my solutions to be x-intercepts, that means that this thing has to be equal to 0. It does not matter if you put equal 0 like to start your function like I did here, or you write the f of x part and then put equal 0 at the end. Does not matter. But if I'm doing x-intercepts, then that means I'm equaling 0. Okay, we talked about that over here. If it's equal to 0, we're looking at x-intercepts. So if I'm going to write the function and I want the solution to be x-intercept, I have to set it equal to 0. And now I want to write a function to describe f of x. So f of x, again, is this guy right here. I can see its x-intercepts pretty clearly. So I'm going to go ahead and write a function based on that, because we know how to write functions based on x-intercepts. So it looks like I've got an x-intercept at -1, at 0, and at +1. So I'm going to write this in factored form as x plus 1, x, or x0, or x plus 0, excuse me, or x minus 0 is fine. If you want to throw your x in front, that's fine too. And then x minus 1. So this part describes f of x. This part, the equal 0 part, tells me my solutions are those x-intercepts. And now let's go ahead and list those solutions. So I have already named them here: -1, 0, and +1. Based on the degree of my function, how many total solutions do I expect? 3, right? Factored form, so I've got to add up my exponents here: 1, 2, 3. I expect 3 total solutions. And then we have 3 real solutions here. So how many imaginary solutions should I expect? 0. Good. And now number 7 says write an equation that represents the solutions that are intersection points of f of x and g of x. So for this one, I'm going to set f of x equal to g of x. We did this in reverse already. So we had the equation and we looked for the intersection points. Now we know we're looking for intersection points. We're going to write the equation. Okay, different graphs here, but same idea. I have an equation for f of x already, so I'm just going to use that. There's no need to reinvent the wheel here. I already wrote an equation for f of x in factored form, so I'm just going to recopy that down here. So x plus 1 times x minus 1. That's my f of x portion. And now I want to set it equal to something that represents g of x. So g of x is my line here. Since it's a line, I'm going to go ahead and write slope-intercept form since it's got a nice y-intercept. So I know my y-intercept is 0. And then to get to, here's another nice point. So to get between these two, I have to go up 1, 2, 3, and over 1. So it looks like my slope is 3. So 3x plus 0. Or just 3x would work. If you like the plus 0 there, you can tack that on at the end. So this is my equation. The f of x portion equals the g of x portion. And now I want to know how many solutions are there. So the solutions, remember, are my intersection points. So I've got one here. And then I got another intersection up here. And another intersection down here. Remember, we're listing only the x values. So this would be -2, 0, and then +2, right? That's the x value there. How many imaginary solutions do I expect from this? 0 again. The degree of our function has not changed. If this were 3x to the 4th, The degree of my function would have changed because the degree over here is 3. If this is the same or smaller, your degree hasn't changed. Okay, so our degree is still 3, and I've got 1, 2, 3 real solutions. That means I have 0 imaginary solutions. Questions for me on our graphs and tables work? Okay, so the thing to watch out for is what are your solutions? How are they represented? Are they x-intercepts or are they intersection points? Remember, if they're x-intercepts, you're looking for where you cross the x-axis and your function will say equals 0. If you're in a table, then your y value is going to be 0. If you're looking for intersection points, that means you're going to have one function equal to another, and that other function might just be a number. That's okay. If you're in a table and you're looking for intersection points, you're going to look for when those y values are the same.